Okay, this is just a real quick video on how to be able to look at a scatter plot and get a rough sense of what the correlation coefficient value R would be. So we'll do that through a test, but let me just real quickly go over some things. First of all, R is always between -1 and +1. You can't, it's impossible, mathematically impossible, to have below a -1 or above a +1. Correlation of 0, which would be right in between those two extreme points, is no relationship whatsoever. Whatever the x variable is has absolutely no connection to what the y variable is. So a -1 is actually much stronger correlation than a 0. And a 1 is also much stronger than a 0. That's one of the weird things here. Whether you're at -1 or +1, either one means your dots are fitting exactly on a single line. So there would be an example of a +1. A -1 would be the same thing, except the line would be going down. So that positive or negative portion only tells us which direction the slope is going. So these two would be positive r's. These two, oh, I guess this one's also a positive r, but this one here would be a downhill slope, so this would be a negative r. And then the closer you are to either 1 or -1, the closer the dots are to that imaginary line, even if you don't see a line. So like in these cases, we don't have a line, but we can see clearly that these points are more closely clustered to some invisible line than, say, these points are right here. So the closer you are to the line, the closer you are to either -1 or +1. And just a quick reminder that you do want to be careful with an R value to look at the graph too. You don't want to just see an R value. All four of these scatter plots have a correlation value of positive 0.81 or 0.82. They all have the same R value. But really this top left one is the only one that's a legitimate description of the linear relationship between these x and y variables, because these dots are scattered randomly above and below the line. This one here is actually a much stronger relationship, but it's not a linear relationship. It looks more like a upside down parabola here. So even though we could mathematically give this a value of r equals 0.81 or 0.82, that wouldn't be an accurate description of what's happening with these two variables. Same here. These actually have pretty perfect relationships, except for this one data point in both cases. In both of these cases, probably this data point is either a data entry error or perhaps from a different population, but it's clearly not from the same population that these rest of the dots are. So only in this case does your correlation coefficient R accurately describe the relationship. So going back here, notice that we have two negatives and two positives. Well, it looks like if you picture a line going through the middle of these, it would be an uphill one. So this should be positive, same as this. These two are the ones that are negatives. So we know that these two scatter plots go with these two negative values. Negative 0.94 is closer to -1. In other words, it's a stronger downhill correlation, and that is what we see here. These dots are much more closely linked to a line than these are. So I'm going to check that. This is the only other negative one there, so that would be a weaker correlation there, closer to 0. Here, this is difficult. So we know that these are positive, 0.65, 0.72. Which of these two are stronger? I would say, and this is a little guesswork, this isn't so important that you know this precise, but I would say that these are a little more closely clustered to a line going through them than these are. And so I'm going to put the stronger correlation, the one that's closer to 1. I'm going to check my answers. All those are correct. Get new plots, and I'm going to continue. Do make sure that when you do this, you first enter your ID of DS15, and that will put us into the same group right here.